Good morning, children. How are you all? I hope you all are doing good. Okay. Stay home, stay safe. Okay. Whatever the classes are coming, no. Every day you just do that work at the same day itself. Okay. So that it will help you. That won't be a burden for you guys for next day also. Okay. So yeah, come to the point. Last two classes we are discussing about the electric current and electric potential and potential difference. Okay, I hope I have convinced you guys about the concept clearly. Okay, if you have any doubts regarding that one, do let me know when we meet. To do for that, what you need to do here, take a pencil and make a note wherever you are getting a problems. We just write down that one on a textbook, or you can wherever you want that, just you make a note. When we meet, you can ask me that. Okay, I can clarify and I can help you about that. Clear? So last two classes we are discussing about the current and electric potential and the potential difference. We got to know what is current, the rate of flow of charges. It is called as a electric current, isn't it? Rate of flow of charges. So what is the formula here? I is equal to Q by T. Q is a charge, T is a time. Time always you have to take it in the form of seconds. Okay. Next point is here, at least for 5 to 6 statements you have to keep it in your mind from the electric current and even potential difference also. One is what is electric current, the rate of flow of charges. Okay. Then second one is what is the formula, that is I is equal to Q by T. What is the SI unit of electric current, that is ampere. If you go according to the theory, that will be what is that, coulombs per second. Okay, because the SI unit of a charge is here coulombs, the SI unit of a time is here second. Okay, to give honor to the scientist, it is taken it as a ampere. Okay, the third point is here, and always you have to keep it in your mind, the formulas are designed by the statements only. Formulas are designed by the definition of the concepts only there. Okay, don't bar head, guys. Don't bar head anything. Try to understand the concepts. Okay, don't bar head. Clear? So the next one is here, what is 1 ampere? Okay, what is 1 ampere? 1 ampere means what here? The 1 coulomb of charge is passing through a 1 second. Isn't it? So that is the definition of a 1 ampere. Means here 1 ampere where you are taking I is equal to Q by T. No, you just ignore this point, guys. Okay, it was the time was there, so I just written the points on the board here. I is equal to Q by T. We know that one. What is the SI unit of a current here? That is A. And what is the SI unit of a charge here? That is coulomb. What is the SI unit of a time here? That is second. I'm just putting here 1, 1, 1. So many times this is asked in the your exam. That is what is 1 ampere? What is 1 ampere? Okay. And for this is the fourth point. So the fifth point is here, very important point, that is what is the instrument we use to measure the current here? What is the instrument to use to measure a current? That is ammeter. What is the instrument here? That is ammeter, right? These are the 5 points you have to keep it in your mind. Okay. Yeah. Next, another 2 points will be there. That is conductors are good conductors of electricity. Why? Because conductors are having freely moving electrons in them. So they can allow the current pass through it, isn't it? And next is here, insulators do not allow current to pass through it because they are not having freely moving electrons in outermost cell. Okay, this is the 6th point. This is about the electric current. We have done one problem also. After that, what we learned about the electric potential and a potential difference. Isn't it? And definition of a potential difference. And what is the formula to find the potential difference there? V is equal to W by Q. What is the W here? V is equal to what? W by Q. What is the W here? Work done. Okay, what is the SI unit of W here? That is joules. What is the SI unit of Q here? That is coulombs. Okay, what is the SI unit of potential difference? That is volt. Isn't it? So joules per coulomb also, it is the SI unit of voltage here. The potential difference here. Also you can say SI unit of a potential difference is volt. This is again the same thing to give honor to the scientist. Okay, it is taken it as the volt. Clear? These are the important points that we learned in last 2 classes we have solved one problems regarding this potential difference. Remaining, different problems we'll see in the next classes also. Don't worry about that. Clear? And all the points I'm giving you as a PDF. Okay? Yeah, just you try to understand the concept. Okay, so this is about we learned, and after we learned this both electric current and potential difference, we came to know about one conclusion. What was that conclusion, guys? We came to know that one conclusion there. What was that conclusion here? What is the conclusion there? The conclusion is here, if there is no potential difference, then there is no current. Current exists because of the potential difference. Why? Because how it happens? How you are saying this statement here? Because for everything there will be some pressure. If the charges are flowing, means there will be some pressure to flow from one atom to the another atom. Okay. If there is no pressure, if there is no movement in the charges, then there is no current is flowing in it. Yes or no? So here they both are related. They both are very thick friends here. If it is not like, if there is a potential difference, there is no potential difference, there is no current. If there is no current, then there is no potential difference. I had given the examples also. If air is flowing from one place to another place, because of the air pressure. Isn't it? If water is flowing from higher land to the lower land, because of some pressure only there. Otherwise they don't flow. You can keep some water on a horizontal place, then it won't flow anywhere. It might be not like this, not like this. You are keeping just in a horizontal way. Isn't it? The same way, there will be some sort of a pressure for the charges to move from one atom to another atom from the outermost shell, which are freely moving in their outermost cell. Isn't it? So they are related like that. It means here our conclusion after learning the electric current and potential differences here, they both are related. They both are related. If there is no potential difference, then there is no current. If there is no current, then there is no potential. It means here they both are related here. Isn't it? So how they are related? How they both are, we got to know that when they both are related. Okay, we got to know that when we are friends or we are something sisters, brothers, we are cousins like that. How? Whether they are from the father side, whether they are from the mother side. Isn't it? There will be some connection, no? So how they are related, that we are going to learn in Ohm's law. That we are going to learn in Ohm's law. Cleared my point here? Clear my point, guys, here? Why we are learning Ohm's law here? Because to know the relation between voltage and ammeter. Current and voltmeter. Current and potential difference. Okay, so to understand that one, I will give you one application example. I will ask you an application example, then we'll go for theoretical and practical way. Okay. So at home, we all are very familiar with this word from our elders. Even we say that our youngers to do this. Like when you on the tube light, when you switch on the tube light, if the tube light will take some time to glow. The tube light will take some fractions of a time to glow. Okay. If sometime what happens, it will do some puck and it will off or it will glow. Okay. At that time, our elder used to say the word. Have you got my point, guys, here? Have you understood what example I am giving here? See, at our home, we are very familiar with the word. Okay. What that word is like when you switch on the tube light. Okay. At the initial start, at the beginning, the tube light will take some fraction of a second, and after that it will glow. It will not suddenly glow like other bulbs, other common bulbs. Isn't it? So it will do some puck sound, or it will take some fraction of a second, it will on. Yeah. So at that time, our elder, if it is not glow, at that time our elder used to say the one word, that is what here? They used to say that one, voltage is less. What they used to say? Voltage is less. They never use the word here, current is not there. They never use the word, current is not there. They use the word, voltage is less. So only this is not going to glow. Yes or no? Yes, so only it is not going to glow at the time which you are going to switch on the board. We all are very familiar with this word, voltage. They use the word voltage. They know the science there. They know the science. Voltage is less. They know, don't use the word current is not there. Isn't it? Then what is this? Current is there. Voltage is less means what is this? That we will learn in the Ohm's law. That we will learn in the Ohm's law. Okay. For that, we need to do one activity. Okay. So I cannot show this one in practically, but I can explain you. I can convince you by drawing this diagram on the board itself. Okay. You just ignore this point. Okay. So here, page number 98, guys. Page number 98. In that, they have given one circuit diagram. Circuit diagram also I have explained you in the last class. That is continuous and closed path of an current. Continuous and closed path of an electric current. It is called as a circuit. Electric circuit. Clear? So what we are learning here today? Today we are learning what is the relation between potential difference and current here. What is the relation between potential difference and current? We all got to know that one. We got a conclusion that one. There is no potential difference. Then there is no current exist there. Isn't it? So how they are related? Let us learn now. What my point? Very simple. There is no need to break your head at all. Very simple concept. Okay, you have to understand. At least it will take maximum 5 minutes, I think. So here, I'm going to draw this circuit diagram. Okay. Just I will put one battery here. Just I will put one battery here. Here I am going to keep emitter. As I told you, here this is the, wherever the bigger line is there compared to this line, then this is a positive sign and this is the direction of a current in flowing, right? Yeah. Here it will be the voltage. Okay. And resistance you are not learning till now. Okay. Then there is no, okay, resistance also will keep. We'll take a resistance. Okay. Next, this is how the current is flowing. And voltage here. And this is our circuit diagram. This is our circuit diagram here. Okay. And this is the direction of a flowing current. This is the direction of flowing current here. Okay. What my exact point is to explain you guys here. Here we are having only one battery. Here we are having only one battery. Battery means what here? Voltage. Here we are having one battery means what here, guys? Voltage. Okay. This is the voltmeter. Don't get confused. This is voltmeter. Voltmeter is the instrument which measures the voltage here. So voltage means where we will get? We will get it from the battery itself. No? This is the sources of a. This is the source no, here. So one battery I have kept here. So what you need to do here? You need to note down the values of emitter and voltmeter. You need to note down the values of emitter and voltmeter. So first column will take a number of cells. Okay. The second column will take current through the wire, that is I, current through the wire, that is I. Next column will take potential difference across the wire, that is V, potential difference across the wire, that is V. Next we'll see that V by I. Next we'll see that the V by I. Okay, this is what we are going to do here. So we are finding the relation between I and V here, current and potential difference. Okay, so first what we'll do, here it will be a serial number. First one, what you are going to do, you are going to add one cell in the circuit. We are going to add one cell in the circuit. At that time, you can note down the current here like a 0.3 ampere like this. At that time, you can note down the current here that like a, when you add one battery here, you can note down the current like 0.3 ampere, something like that. And here you can check the voltmeter, voltmeter in a voltmeter also about the voltage. It will be like something like 5 volt. It is not just I'm giving you approximate value, guys. Don't think that it only will get this much. So 5 volt like this. So you can write like this. There is no need to find this one. Just I'm writing here. Okay. So what you need to do here? This is how you need to do first step. Means here. In the circuit diagram, you are just going to add a one battery and you are going to check the current and the voltage there. How much current is there? How much current is flowing in a wire Okay, and how much voltage is there in the wire. Okay, so next comes here for a second step, second series. What you are going to do here, you are going to add another battery here. It means here you are going to add another battery. Okay, at that time you just notice, you just note down the value, respective value in ammeter. You just note down the respective value in a ammeter. What you can see there? You can see in the ammeter, the current is more here. The current is here more. The current SI unit is ampere, so I am written here A. Okay, the current is here more. Yes or no? When current is more, let us go to respective voltmeter there. What we can see here, even voltage also more here. Even voltage also more here. Understood? The same thing you can repeat for a third time also. So again you add one more battery to this circuit. Again you add one more battery to the circuit. So this is the third battery. Okay, so when you add this third battery, you can observe that one. The current will be more here, like a 1.2 ampere, something like this. And even voltage also more here, 1 volt like this. So what you get to know by seeing this activity? What will be your conclusion, guys, here? How the current and potential difference, voltage is related here. They both are definitely related. It means here, whenever the current is more, voltage also more. Whenever the current is more, whenever the voltage is more, current also more. Whenever the current reduces, voltage also reduces. Whenever the voltage reduces, even current also reduces. Understood? Whenever the voltage reduces, current also reduces. This is the relation between potential voltage and the current here. If more current, more voltage, less current, less voltage. Okay, this is you can see here. If a less current here, less voltage. If the more current, more voltage. If you are going to increase the current, voltage also go on increasing. Understood? Then how they are related? We'll see in this Ohm's law. Come to this point. I hope it is clear here. Very simple. If you are going to increase this voltage, if you are going to increase the battery in this, so you can see the current is also increasing, even voltage also increasing in the voltmeter. Okay. If you are reducing this, this is also gets a reduces. Clear? So come to this one here. So what is Ohm's law here? Current flowing through a circuit is directly proportional to voltage. Current flowing through a circuit. Current flowing through a circuit, it is directly proportional to a voltage. Okay, how we will write that one? V is directly proportional to I. Voltage is directly proportional to current. This is called here Ohm's law. Very simple. This is called here what here? Ohm's law. You may get the question like what is Ohm's law? So what you need to write here? The current flowing through a circuit is directly proportional to voltage. Don't get confused. The students have a tendency to do the mistake here itself, like instead of writing here this one through a current, they will write voltage. Here they will write a current. Keep it in your mind. Last word in the statement will be voltage. So first will be current. First will be current. First current flows, then only voltage. No. So yeah. Current flowing through a circuit is directly proportional to voltage. So this current is directly proportional to voltage. Remember like this. Current is directly proportional to voltage. Got it? So voltage is, current is directly proportional to voltage here. This is called here Ohm's law. This is called here Ohm's law. Understood this concept? Next come to, ma'am, what about this? You may ask me question. If you are like here in the physically, if you are here means you can ask the question, ma'am, what is this? What is the work of this? Okay. For example, guys, in the mathematics, we are learned about the algebraic expressions, right? So here, if you have anything like 3 proportional to 4, if I ask you, solve this one. If I ask you, solve this one, like 3x is equal, is directly proportional to 4. Can you do this? Cannot do. You cannot do, no. You need some equal sign in between. If I given like this, like a 3x is equal to 4, then definitely you can do x is equal to 4 by 3. So you definitely can get the value of x here, isn't it? See, if we have a v is directly proportional to I is directly proportional to v, means if we have like this, then how we will find out voltage and current if you are having a resistance in it? How you are finding the current and voltage if you have a proportionality sign in between them? You cannot do. You want one equal sign in between them. So we are taking resistance as a constant. So we are taking here resistance as a constant. This is how we can introduce the resistance in a circuit here. Okay, you cannot find out the values of V and I because V and I are directly proportional to each other. So here you cannot find the value directly if you are having the sign directly proportional. So you need to take one constant thing in between them. That is a constant here. What is that? That is resistance. Is that here? That is the resistance. The resistance, it is shown in like this in the circuit. This is the resistance. Clear? So here, if the resistance comes here, how we will do this one? Resistance, it is the SI unit of resistance is here ohm. The SI unit of resistance here ohm. This is the sign, and if you write in this word, that is ohms. Okay, this is the SI unit of a resistance. Okay, we know the SI unit of a V, we know the SI unit of I, then we must know SI unit of R also. No? That is ohm here, because if you find the value of R, then you have to definitely have to put the SI unit of there, right? So that is ohm here. Clear? So now how we will write this one? V is equal to RI. So we know that one, that is V is directly proportional to I. Okay, current flowing through a circuit is directly proportional to a voltage. Then if you want to make this one equal, then you are taking one constant, that is the resistance. So we are writing it is V is equal to R into I. V is equal to R into I. Next, what is R here? This is resistance. What is R here? This is resistance. What is the SI unit of resistance here? That is ohms. How you write this one? This is the sign of a resistance, isn't it? As I explained you before while explaining about the current and voltmeter, how to you can interchange the this one values. The formula is our basic formula is V is equal to RI. This is the Ohm's law. Enough this much. This is the Ohm's law here. V is equal to RI. Okay. So if you get the value of V and I, if you need to find R, means how we will do? R is equal to V by I. You can write R is equal to V by R. Or else you can write I is equal to V by R also. These are the interchanging of the formulas so that you can find the, if you get the respective values, you can find the remaining things, respective things there. Understood, guys? This is the formula to find the values of I, R and V here. Okay, this is about the Ohm's law. This is about the Ohm's law. Okay, yeah. So any doubts here regarding this? I hope it is cleared here. So what we all learned now? Electric current, potential difference and Ohm's law. Okay, what is Ohm's law here? Current flowing through a circuit is directly proportional to voltage. Current flowing through a circuit is directly proportional to voltage. Okay, so that is V is directly proportional to I, voltage, current. Okay, so you cannot calculate V and I directly if you are having a proportionality sign. Okay, how they are related means when you are voltage increasing in the circuit, current also increases. If voltage is reducing, current also reduces. Okay, so this is called here Ohm's law. Whenever asked what define Ohm's law means, you have to write this definition and you have to write this. V is directly proportional to I and even enough this much. Till here you have to write. Okay, this is called here Ohm's law. Okay, so you cannot find out the values of V and I if you are having a proportionality sign in between them. So you need to introduce the constant in that. So that constant is called here resistance. Okay, that resistance will be the constant then. So when you are introducing the resistance in this, that is called here Ohm's law. That is here V is equal to R into I. Okay, the SI unit of resistance is here ohm. This is the sign you can write here. That is OHM, or else you can put the sign here. Okay. According to the given values, you can interchange this formula and you can find the R, V, and remaining respective things which is asked in the question. Clear, guys? I hope it is cleared. Okay. So yeah, this is about the today's class. Let us learn remaining things in the next class. That is about the factors on which the resistance of a conductor depends. Here, very interesting concept is there in next classes. Okay, the problems which is related to this one, we'll see in the next class. Yeah, we'll see in the next class. Okay. Okay, thank you. Take care of yourself, guys. Okay. See you in the next class.